Hello students of 10 Maths General and welcome to exercise 2F, simple interest. Now before we get into the maths behind this topic, let's just define some terms for ourselves. So first of all, what is interest? Interest is just a way of representing the growth and value of things over time. It specifically represents this growth though as a percentage of original or current value of items. So here's some examples. When we invest money, one way to represent the growth in our investment is with interest. Likewise, when we take out a loan, the value of money that we owe to the people we took the loan from will grow over time due to interest placed on the loan by the people we borrowed it from. Now, this is because if I borrowed out $10,000, there's actually no incentive for me to pay it back other than my own personal responsibility to do so, unless the people I borrow it from uh, put some interest on it. So, what that means is I borrow out $10,000, but the money that I owe will grow over time as an incentive for me to pay it back on time or even faster if I can. That's also the motivation for the people who will loan out money. That's their motivation, is that they could lend out $10,000 and then by the end of the loan, you might pay back $15,000. So that means they've made a profit of 5,000. If interest didn't exist, there would be no reason for them to lend you the money in the first place. So interest makes it sort of a win-win deal. You get the money you need right now, with your loan, but also they get a profit by the end of the life of the loan. So both parties benefit. Now, let's define what interest rates actually are. So the level of interest that a loan or investment is subject to is expressed as a percentage, like we said, and it's this percentage that is known as the interest rate. So for example, an interest rate of 5% per annum, and per annum means per year, means that the value of the given loan or investment will grow by 5% per year. So if an interest rate of 10% was on a loan, the loan would grow by 10% per year. If there was a interest rate of 50%, then the loan would grow by 50% per year. And just a quick note as well, interest rates always have a time period attached to them, and that tells us how often interest is calculated. Now, for most of these simple interest questions, it will be a per annum time period attached. But when we get into compound interest later, you'll start to see different periods for the interest. Now, here is the formula that we'll be using for simple interest. It says I equals PIN. Now, in year 9 and earlier, you may have used a different formula that said SI equals PRT over 100. Now, both of these formulas actually do the same thing. We'll just get into where this 100 comes from when we start talking about the lowercase I in this formula here. The reason we're showing you this new formula now, though, is that the formula sheet that you get in year 10, 11, and 12 for general maths has this formula on it, the new one that I'm showing you now. So it's a good idea for you to get used to using this formula because if you ever forget it, the formula sheet won't tell you PRT over 100, it will tell you PIN for simple interest. Now, the way this formula works is it says capital I equals PIN. So the interest accrued over a certain time period, so that's the actual amount that the value grows by, is equal to the principal, which is the original amount of money borrowed or invested, multiplied by the interest rate, making sure that it's converted to a decimal, and then multiplied by the number of years. So what this does is it takes our original amount of money. So let's say it's $1,000. I'm investing $1,000, and then it multiplies it by our interest rate. So if this is a 5%, for example, and I've invested $1,000, if it grows by 5%, that means I'm multiplying by 0.05, because that's 5% as a decimal. I've divided the number by 100. So that would mean $1,000 increased by 5%. But then the n on the end just makes sure that happens n amount of times because interest is being collected every year. So if it is collected for 6 years, for example, I multiply by 6 there. So what that's saying is 1,000 times 5%. So 5% of 1,000 and then multiply that by 6 because it happened 6 years in a row. So that's how this formula works, and that will start to make even more sense as we see some actual examples. Before we do that though, here's an important note. The formula that we just looked at, I equals PIN, what it's calculating is capital I, which is the interest earned. So like we said, the interest earned is just the amount that our value increases by. So that's not the final amount. So for example, before when I was talking about taking out a loan of $10,000 and then at the end I'm paying back $15,000, that means in that case that I was equal to 5,000 because the value of the loan increased by $5,000. Okay, but that's not telling me how much I paid back in the end, is it? To really do that, to calculate the final value of an investment loan, we must add the interest. So we have to add the interest that was accrued to the original value. And the original value is what we call our principal before. So that gives us this formula here. It says A, the final amount, is equal to our original amount, P, the principal, plus the interest earned. Okay, so for example, I could borrow out $10,000, and then using my simple interest formula, it turns out that I earned $5,000 of interest on the loan, and then of course that equals $15,000. So this is saying I borrowed out $10,000, it earned $5,000 of interest, so therefore I paid back a total of $15,000. So that's the difference between P, not P. That's the difference between I and A. Some questions might ask for one or the other without using the letter like that, though. Some might say how much extra interest was earned. In that case, I is what we're looking for. And some questions might say, what was the final amount that was owed? Or what was the final value of the investment? In that case, A is what we're looking for. So we need to be careful. We need to think about which formula am I using, which part of the formulas am I looking for. So now that we know that, let's take a look at two examples. So this first one is just using the simple interest formula, and then we'll be rearranging it as well. Now we're not using this version of the simple interest formula from the textbook. We're going to be using I equals PIN. Now A says, calculate the interest when $600 is invested at 8% per year for 18 months. So this is a simple interest question straight away. So I'm going to write my formula. So this is a really helpful way to start these questions, is to just write the formula and then fill it in from there. So now I'll fill in all of the things that I know, and then I'll see what's left over. So $600 is what was invested. That means $600 is the original amount, which is what P stands for here. So that means I put 600 here times. It's an interest rate of 8% per annum. So that means I need to write it. So 8% PA is equal to 0.08. Because 8% as a decimal is 0.08. So times 0.08. And then it's for 18 months. So now 18 months is not a number of years. So what I need to do is I need to represent 18 months as a number of years. So the way that I do that is I say it's 18 months out of a total of 12 months per year. Because that fraction will convert 18 months into a number of years for me. Now I could do that calculation separately over here. I could say 18 months divide 12 months per year is equal to 1.5 years. I could do that separately like that, but keeping the fraction in here is fine as well. So that means I can just type in 600 times 0.08 times 18 over 12 on my calculator, and I'll get the final answer here. Alrighty, and the answer is $72. Okay, so this $72, that's what capital I is. And if we remember, capital I represents the interest earned, so the extra money earned on the value of the $600. So over the 18 months, the $600 earned an extra $72. So that's answering A because we were looking for capital I, we were looking for the interest. If we were asked for the final amount instead, it would really be 600 plus $72, which is $672. Alrighty. Now B says the annual interest rate when $5,000 earns $150 of interest in 2 years. So here my unknown is not capital I, it's actually lowercase r. Or we call interest rate lowercase I. So let's take a look. I'll write my formula because I know it's simple interest. I'll fill it all in and then see what's missing. So $5,000 earned $150 of interest. So where I put the interest earned is over here with the capital I. Now I don't know the interest rate, that's what I'm trying to find out, but I do know the number of years is 2 years. So that's just times 2. So now I've got a one-line equation here, and I've got only one thing missing. So that means I can actually calculate what's missing by using some algebra. So 5,000 times 2, I'll simplify that first. That's 10,000 multiplied by I. And then I've got 150 still on that side. Now to get rid of this 10,000, I need to do the opposite of the way it relates to the I there. So it's 10,000 times I. So the opposite will be to divide by 10,000. And what I do to one side, I have to do to the other as well. Okay, so 10,000, 10,000. Cancels 10,000. And then I'm left with I equals 150 divide 10,000. So on my calculator, I'll type that in, and I get 0.015. Now that's the interest rate as a decimal. So now let's just express that over here, 0.015. Let's express that as a percentage by multiplying it by 100%. And then I get 1.5%. So that means in B, they were asking us what annual interest rate would be able to make $150 of interest from 5,000 over the course of 2 years. And the answer is 1.5%. So that's the interest rate needed to make $150 worth of interest on that 5,000. Alrighty, let's take a look at another example here. So it says $3,000 is borrowed at 12% per annum simple interest for 2 years. So A asks us, what is the total amount owed over the 2 years? So they're not just asking us for how much interest is earned, they're asking us what is the total amount owed at the end of the 2 years. So that means we're going to need to find the interest and then find the final amount from there. So I equals PIN. My principal is $3,000. My interest rate is 12%, but I need to turn it into a decimal, so that's 0.12. And then my N, my number of years, is 2 years. Now this is just a bunch of numbers, so I can type them into my calculator. 3,000 times 0.12 times 2 is equal to $720. So that's the amount of extra interest that was earned on this loan. But part A actually asks us, what is the total amount owed over the 2 years? So that means I need to find the final value of this loan. So that's P plus I. A equals P plus I. And in this case, the principal was $3,000 and the amount of interest earned was $720. So therefore, the final value of the investment is $3,720. So that's part A. Now part B says, if repayments of the loan are made monthly, how much would each payment need to be? So let's look at what we're dealing with here. We're dealing with paying off $3,720 paid off over 2 years. But the repayments are monthly. So with monthly repayments. Okay. So 2 years actually gives us 24 months to work with. So to work out our monthly repayment, what we need to do is we get our $3,720, that's the total amount, and we divide by the 24 months that we have available to pay it off. Because we've got 24 months, what we're doing right now is working out how much does our repayment have to be each month in order to pay off that 3,720. And the answer is $155 per month. So what that means is each month, if we pay back $155, at the end of the 2 years, the 24 months, we will have fully paid off the $3,720. Thank you, Year 10. That's enough information for you to be able to attempt the exercise questions in 2F. Remember though, you can always contact your teacher during lesson times for help via email or perhaps via Zoom as well. So don't forget to tap into that resource.